Hello, I'm JW. This time it's surge protection, and continuing the series, this is actually part 5. Now this time we're going to look at how you would actually connect these things to an installation, and we've got this thing to have a look at as well. We're not going to be taking this apart because this is going into an actual installation, but nevertheless we'll have a look at this and see how that could be connected, and also certain other options of how you might actually wire these things in, say a consumer unit or some distribution panel, and there's various choices, and there's several things you need to be aware of when doing that. Now before we get to that, we'll just cover this thing here quickly. This was in the previous episode where we heated it and it didn't really work as well as it should. And a number of people commented that when it was squeezed in this vise, it would have deformed the plastic and prevented this from moving properly, but that's not actually the case. I mean, this here moves perfectly freely there on the spring. And the back of this is filled with this white resin, which is extremely hard, so that's a fairly rigid item. And despite its appearance, this orange plastic case is not some flimsy, bendable piece. I mean, trying to squeeze that in there, and it really doesn't move at all, so it is actually an extremely rigid and robust item there. So, and we'll still have 2 more of them there to do something with at a later time, so that may be coming up once I've got some more equipment to do something with those. Now let's have a look how you would actually install such things. Now, in terms of the electrical connections, it's pretty much the same as any other piece of equipment. On this one we've got the earth here, line and neutral, so it's just 3 wires which connect to those 3 things, generally inside the consumer unit for this style, or in some distribution panel or whatever. You can also put these in a separate enclosure on their own, but in any case it's just the 3 wires there. If you have a 3-phase version of this, then it's pretty much the same, earth and neutral, and then just have 3 line connections, 1 for each phase, rather than just the 1. So again, no real surprise there, pretty much the same as connecting up to any other piece of equipment. But one thing that is important on these is the length of the wires that actually connect to the surge protective device, and this is in the wiring regulations, which we'll have a look at in a moment. But the length certainly is highly significant, and the idea is to have the length of the wires from the terminals as short as possible, and that's the distance between this thing and the rest of the installation. Now this is another type of surge protection device. This is a wireless one. This has an isolator and the surge protection parts in it in the same unit. This is designed to be used as a separate standalone item. Basically it's your supply goes in the top there, so line, neutral and earth, and then the outgoing things come out the bottom. And this particular one, let's have a quick look inside here. It's essentially just the standard 2-pole isolator there, line and neutral, and then we've got the surge protection device over here. And this has the removable cartridges. In this case they're a lot easier to remove, so again it's just the thing there, 2 terminals on the back, and these have a plastic peg here which is basically keyed so it only fits into one of the positions, as the other side, as you can see there, is the other way round, so you can't put the wrong one into the wrong position, as they've made 2 types there. This is the one that goes between the line and earth, and this is the one between the neutral and earth, so those go in like that. But in terms of the wiring, it's pretty much exactly the same. Earth connection here, it's got 2 terminals for that, and line and neutral. Now so this is a standalone item, and it's intended to be placed as your main isolator with the surge protection in it, and the connections here just go across the bottom. That's actually how it's supplied from the factory. Now we're not going to be taking this one apart because this does have to go into an actual installation, and I didn't get this free or anything, I actually purchased this myself, so obviously we're not going to be destroying that, but it's just an example of the possible way you could install these, say as a separate standalone item rather than putting it inside the consumer unit. Now let's have a look in the regulations. This is the blue 7671/2018 version, the 18th edition, and the particular section here is 534, and this is part of it, so selection and erection of surge protection devices. And there's a whole lot of text in here. We're not going to go through the entire thing. Obviously you can get your own copy and read this at your leisure. So essentially it's all contained within here, and if you have a look over the page here, it covers at the top here, for example, where you would install them. We've covered this in previous videos, so it's the same as we saw there. At the origin it's type 1 and or type 2. Distribution circuit is 2 or possibly 3, and then close to centre of equipment, again you can add those type 3s if you want. Now I've got this diagram here, 534.8, and this shows a theoretical connection of a surge protection device. So we've got the line conductor here, or the live conductor. Live could of course be line or neutral. and the protective earth conductor here at the bottom, and then between those we've got the surge protective device, which is basically one of them, and we've also got the overcurrent protective device, which is going to be a fuse or circuit breaker or something like that. Now there is a difference in some of these. These particular ones require an external overcurrent protective device, and that's quite often provided with a circuit breaker just next to that onto the line conductor. Some of these from some manufacturers do actually have a fuse built inside, and that's basically the overcurrent protective device here. Whether you actually need a separate circuit breaker or not really depends on the manufacturer, so just follow the manufacturer's instructions for that. That will also tell you what size of circuit breaker or whatever to use. Certainly for a smaller domestic installation, 16 or 32 amps is a fairly common choice, but say some of them do actually have a fuse built in. I'm talking usually a ceramic type of fuse inside, not to be confused with the thermal thing which we saw in the previous video. They all have those in. That's basically what operates the indicator window and just melts, but it's that plus an actual normal sort of cartridge type fuse built inside. So some do, some don't, but say to follow manufacturer instructions as whether you need an external overcurrent protective device or not. Now this is where the links thing comes in, and we can see what 3 links here to A, B and C. Obviously if this is inside the actual whole assembly, then of course length B won't exist, it's just going to be length A and C because you won't see what's inside the device. But if you've got a separate, say, circuit breaker outside, and that just loops over to the surge protective device, then of course length B will exist as well. So A is between the live conductor and the overcurrent protective device. Length B is between the overcurrent protective device, say circuit breaker, and the surge protective device, and length C is the bit between the surge protective device and the earth conductor. So fairly straightforward there. Now the bit here is really the main meat of this, not going to be the whole thing, but consideration should be given to limit the total wiring length of conductors between connection points of the surge protective device assembly, which should preferably not exceed 0.5 metres and in no case exceed 1 metre. So the total of these should not exceed ideally half a metre or 50 centimetres, and your absolute maximum is 1 metre. Now in reality you want to get it as short as actually possible, so even half a metre really is probably going to be your absolute limit. Longer is far, far worse, as we'll see a bit later on. And there's a bit at the bottom here which says if the total wiring length as defined there exceeds half a metre, then you've got various options here. But really the option is to make the wiring length less than half a metre, because some of these options here are certainly not optimal, and there can be other problems with having excessive lengths of wiring. Now there's a diagram here which attempts to explain what lengths of wiring we're actually measuring, but it's not particularly helpful and it's rather confusing, so we're not going to be bothering with that. Let's just move away and draw one ourselves. Now here we've got a typical set of wires, so line, neutral and earth, as you would find in the installation. And in terms of connecting it, so there are several ways you can do this. What we're going to show first is what basically is going to be the wrong way to connect it. So you can imagine that over here this would be, say, the supply coming in, that might be your supplier's fuse or whatever, and then this will actually go to the installation, so consumer unit or whatever else over there, and then we'll call this side the supply over here. So this could be like meter tails or whatever coming in from the meter there over to the consumer unit or distribution board or whatever else you've got. Now one method of connecting a surge protected device is to locate the thing over here in a separate enclosure, and that would be inside there like that. Again, that may have a separate circuit breaker in there with it as well, or maybe not, depending on the type you've got. So separate enclosure, and they're actually fairly readily available. And then to connect it, what you would do is to basically take the wires from here with some kind of connection box and bring those across to the surge protective device over there. So they will just come over like that, and of course the earth would come over as well. And then this here could be, say, a set of terminals or connection block or something like that, just basically tapped off of the incoming wires there. Now this is a fairly poor way of connecting it, and the length that we're looking at in this case is the length of these wires. So it's the length of the protective conductor, so that would be from here to here, and also the length of the live conductor as well, so that would either be the neutral or the line. The line is longest here, so we'll use that one, so that then would be the length to there. So I've got one length here and one length here, so it's the two of those added together. Now bearing in mind that the maximum was actually 50 centimetres, and it's pretty easy to see that straight away we've probably exceeded that by a huge amount, because 50 centimetres is pretty much nothing, and if these were the same length each, that means each of those would only be 25 centimetres length absolute maximum. And let's face it, here's the wire regulations book. This is nearly 30 centimetres across, so that's really no distance at all. And it's not just the actual length between the two pieces of equipment, so it's not the length between the casings, it's actual length of the whole wire. So in this case it would be from the actual point it connects here, all the way through outside the casing, outside there, inside the casing, and then into the terminal. And of course if this sort of looped underneath and came around the back, again that's all adding extra length. So this sort of arrangement where it's just coming off, as I say, a stub or a just a sort of direct tap off of the main line, pretty poor choice in terms of installation, because you've got all this extra length here. Almost inevitable it's going to be longer than the maximum ½ metre which was suggested. Now if you absolutely must do it in that fashion, in other words you're going to have the surge protector device in a separate thing with a set of terminals on the top, then there is a much better way of doing it, and that's to do it like this. So let's have the protective conductor coming along, and it will come across to the device here, and then it would come back out and continue to the installation. And it's the same with the other conductors, so I'll bring the neutral across here, and also the line in the same arrangement. Now in this case this is far better, and the distance here is effectively 0, because all the wires are coming to the surge protector device and then they're going back and obviously connecting to the installation over there. So compare that with this one where we had the wires going across and this was sort of just tapped off on its own set of wiring. That's quite a large distance involved there. But in this case, because the wires actually come across to it, the distance is effectively 0, and say this tiny little bit here where the terminals might be, so pretty much as short as it can possibly be. Now the disadvantage with this is that you're going to have quite large terminals on the surge protector device, but of course that's just a question of selecting the appropriate piece of equipment. So if you must have the wires coming across, going in and coming out on the same side, that is a far better way of doing it, and it sort of minimises the distance there pretty much down to nothing. And another way you can do it, which is similar to that Wilex item we saw previously, is you have your surge protector device here, and as with the Wilex one it's got two sets of terminals either side, so your wires can come in to the device and then just go out the other side. And of course the same with the other conductors as well. And in the case of this, again, the distances involved are pretty much 0. It's just any sort of internal connections within the surge protector device or whatever you've got there. So again, supply coming in, surge protector device in the middle, and then going out to your consumer unit or whatever. And again, in this case, the measurements, distances are pretty much going to be 0, because it's all contained within the same thing in there. And have a look at this Wilex example. Your supply would come in the top here, so line and neutral coming in the terminals here just on the isolator. Earth connection goes in the top there, as marked here. And then at the bottom here is where your supply continues to your installation, so obviously controlled by the isolator. And we've got these bars that come across. Just slide that away, it's just the copper underneath. So line and neutral come across to the device, and then your earth connection, so it goes on the top, and your outgoing earth connects to the other terminal there. So again, that's the same as that sort of point wiring that we saw in that diagram. So in the case of this one, the earth wiring is basically 0 distance as it's coming in and going out using the two terminals, and the length of the other is basically this piece of copper here. It's just basically between here and here. So again, that's only a few centimetres in length, keeping it as short as possible. And the other one there, pretty much the same. So that's really the ideal arrangement. So it's extremely short, pretty much as short as you can get it. And again, it's right on the wires there. They just continue straight through. And if you've got a type like this, which will go in your typical consumer unit, the distances are the length of wires between these terminals and the terminals in the consumer unit. So in case of the neutral, that just goes from here to the neutral bar. So you want to make that again as short as possible, generally only a few centimetres there. Again, the earth, you want to make that as short as possible, although it's nice to put these in a nice tidy way and sort of route it around the outside of the box. In this particular case, it's better to take it simply directly from here straight to the earth bar, again making that as short as possible. And the line one, if you have a separate circuit breaker there, it's essentially the distance from here to the circuit breaker, and then also the distance from the circuit breaker back to the main switch. So again, it's just generally a small loop on the top, just a few centimetres in length. So if it's in the consumer unit, not a problem, but do be aware of the fact that the neutral ideally is as short as possible. Don't sort of take it up and underneath and round the back in a nice tidy way, because obviously you can get to that 25 centimetres or so extremely quickly. Bearing in mind it's two added together, so if you've got 25 centimetres here and here, then that's two obviously is adding up to 50. So keep the wires as short as possible, or do it in a separate enclosure and fit it on with the wires coming in and going out of the same piece of equipment. Now the reason these lengths are absolutely critical is to do with inductance, and it's actually the inductance of the individual wires themselves. So basically this one here, and either the neutral or the earth, depending on where the current is actually flowing. Now of course a wire, just a straight piece of wire, does have inductance, but it's incredibly tiny. So in normal circuits things, it's really not something you would consider because it's incredibly small. But I'll just redraw this here. So we've got basically the line conductor coming through to the surge protection device, and then say the neutral going back. So say the surge was between the line and neutral. So it's the line conductor here, surge protection device, and then the neutral going back. So three things basically in series there. Now if I've redrawn that here, essentially it's the same idea here. We've just got the two conductors, length of wire, surge protection device, and another length of wire. And in this case these pieces here are the lengths that need to be under that 1 metre or supposedly 50 centimetres in other cases. Now inductors, you might think of it typically, say, a coil of wire. So you might have a wire coming in and a big old coil of wire like that. And property of an inductor is that if you, say, put it in series with something, and say you might put it in series, say, with a old type sort of fluorescent tube there, and if you connected 230 volts to the ends of that, then what would happen is that the inductor here, or the choke, or also called a ballast, would limit the current that can flow through the fluorescent tube. And this is important because if you just connect a normal fluorescent tube across the supply and it actually is lit up, there's nothing in it to limit the current, so of course the tube is destroyed. So this just limits the current that goes through there, and it is just a big coil of wire normally wound on some kind of magnetic or metal form. And because it's basically appearing as a resistance there, what you get is a voltage drop across it. So if that was 0, that was your 230 volts there. What would happen is the voltage will be divided across this. So say here you might get sort of 100 volts or something, and then the other 130 would be over there. So that's perfectly fine, and that will sort of represent a fluorescent tube kind of arrangement. Now what might be less obvious is that although this is just a straight piece of wire, this does actually have some inductance as well. And of course the inductance of a straight wire is absolutely minute. It's in the sort of microhenries kind of range, so in normal applications at 50 hertz or whatever, to not even significant, so tiny that makes no difference to anything. But of course surges are not 50 hertz electricity coming in here. It's a very short and very sharp and spiky kind of pulse, so even a tiny little bit of inductance here can be significant when you're talking about very high rise time or intense pulses there. And the other thing to consider here as well is that the current that flows when you've got a typical surge going on can be extremely large. And again, quite a large voltage across this, possibly many thousands of volts. So what effectively happens here is that the inductance of this wire, let me just draw this in here, actually ends up putting a voltage drop between these 2 points. And of course the same thing happens on the other conductor as well. So between here and the conductor there, so you get a voltage drop across the 2 pieces of wire. And for a fairly large surge, and say you had a metre of wire or something, this voltage drop here can actually be something like, say, 1,000 volts or even more if you put extremely long wires in. So what might happen if you had, say, a surge coming in here and it was, say, 10,000 volts there from some sort of nearby lightning strike or something like that, what should happen is that the surge protection device will essentially conduct when that huge voltage appears, and then the voltage across the surge protection device will be considerably smaller, and this is actually printed on the front of the devices. So in the case of these orange ones, it's 1.5 kilovolts, so let's put that in there. So what should happen is you get 1500 volts across the surge protection device, so the bulk of the 10,000 obviously is removed, and you only get 1500 going across the equipment to the installation. But if you've got a big voltage drop here and here, due to the great length of wire you put in, say, might put a meter on each side or something ridiculous like that. You're going to get 1500 volts here, but because of the voltage drop here, you're also going to get, say, about 1000 volts there, and you might also get another 1000 volts over there as well. So just by putting long wires in, you've actually reduced the effectiveness of this device, because now, if your 10,000 volt comes in, you're not going to be getting 1500 volts at the other side here. You're actually going to be getting 1500 plus the 2 volt drops here. So in this case, rather than the 1500 as the thing was designed for, you would actually get around 3500, because you're actually adding in those extra 1000 volt drops as well. And of course that's massively reduced the effect of this thing. That is probably quite enough to still cause damage to equipment connected downstream. And of course, in an extreme case, if these were really long, you might actually end up completely eliminating the point of having this at all. So this is why this length here is absolutely critical, and it's not a case of when you get up to 50 centimeters bad things happen, or when you get to a meter it's no good. If you start out at 0, the surge protection device is as effective as it can be, and as these get longer it gets less and less effective. So really it's not about thinking about, say, 50 centimeters or less. It should be about making these as absolutely short as you possibly can. And say one way to do it, say with that Wilex example we saw earlier, just having those extremely short little bars underneath, literally in the order of 2 or 3 centimeters or something. So shorter is always better. The 50 centimeters or the meter listed in the regulations is really an absolute maximum, and you don't really want to be getting anywhere near that. So that's surge protection devices. And the length between the surge protection device and the conductors that supply the installation is what's really important here, not the length between the thing itself and the meter, fuse or anything else. So in this particular case, this is a standalone unit. The supply comes in the top, comes out the bottom, goes to your consumer unit or panel or whatever. Surge protection device is right there next to those conductors, so the only distance involved here is just those 2 tiny short bits on the back here. And the earth on this one comes in the top and then goes out as well, so that's pretty much 0. If this was a consumer unit, pretty much the same deal. That was your main switch in a consumer unit. Supply coming in the top, out the bottom is your bus bar, and then your neutral going up to the neutral bar. And again, it's the same deal. It's right next to those conductors coming in. So again, it's just those tiny short pieces on the bottom. Other thing to consider here though is that in a consumer unit you'd have your single earth wire from here to the earth bar in the consumer unit. That distance is part of it. So unlike as you would normally do a consumer unit properly, is to loop it up and have it all properly shaped around and everything. Not necessarily a good idea here, because that distance could easily add up to quite a bit. So ideally you want to have it from the earth point here straight to the earth bar, keep it as short as you possibly can. But in the consumer unit they're not normally a problem with distance. What you don't want to do is to have your main switch or consumer unit or whatever here, and then put this surge protector device over here in a separate thing and just have 3 wires going over to it, line, neutral and earth, because that is the critical distance, and by putting it over there on its own you've extended that massively, and even at that sort of distance that's half a meter gone already. 25 centimeters there, 25 centimeters coming back, that's your half a meter, so you want to definitely avoid that. So separate enclosure. Make sure the wires come in and go out as well, or in the consumer unit, obviously, same deal. You do not want a separate box with only the 3 conductors to it, because that's going to be way over the half a metre, in many cases way over the metre as well. Now there is another possible option which is not in the wiring regulations, it's in another publication. A link to that is in the description of this video, and it actually shows twisting the conductors together if your surge protector device is in a separate thing with just the 3 conductors going to it. Now the idea of that is that by twisting them together you're going to reduce the inductive effect of that, but the problem is that if you twist wires together you're going to have to make them longer, because as you twist them they obviously need less space to contain themselves. So just by doing that you'll already increase the length even more, so not really a valid choice. And ultimately if it's that far away anyhow there's something wrong with the design of it, so you might want to rethink where you're installing it or locating it. So that's pretty much it for this video. Until next time, thanks for watching.